Alright, welcome to my first video. We're going to be working through this book right here. We're going to look at section 1.1 today. Mainly I'm creating these videos for you guys so that you can watch them if you need to. If you miss class for whatever reason, you can still access the lesson. I'm going to go quickly through. I'm not going to hit every single topic. So I do expect you to read the book. It is written for you to read. Think of it as you have a whole book of notes already. So this is just in addition to what you get in class, and if you miss class, you can hopefully catch up. So section 1.1, let's see, what does it cover? Using the distance formula, the midpoint formula, graphing equations by hand and plotting points, graph equations using a graphing utility. So we're going to be using the TI 83 or 84 calculator. Find the intercepts from a graph, use a graphing calculator to create tables, and use a graphing calculator to approximate intercepts. Alright, so first thing I'm going to start off with, I guess, will be the distance formula. So let's say if we have a coordinate system, this is a Cartesian coordinate system. And just a quick review. This is the x-axis. This is the y-axis, right? The coordinate system is broken up into 4 quadrants, and it goes counterclockwise this way. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Alright, so coordinates in this quadrant are all positive, since this is positive x direction and that's positive y direction, so these will all be positive in quadrant 1. Quadrant 2, x will be negative, but y will be positive. And in quadrant 3, they're both negative because you go left, which is negative x, and you go down, which is negative y. So that's negative. In quadrant 4, you go right, which is positive x, but down, which is negative y. So that's positive, negative. Alright, so let's say we have 2 points on a graph. So let's put one right. Here. So go ahead and guess what is that coordinate. So this is, remember, it's a review. I know it's easy, but just to remind yourself, what is this coordinate? And we'll put another one right here. Alright, so we'll call this point A, and we'll call this point B. So what are the coordinates for these 2 points? Well, this one, we go over 1 and we go down 2, and it's in quadrant 4, so it's positive 1, negative 2. In this one, we go to the right, which is positive, and up, which is positive, so it's 1, 2, 3, 4, 5, 1, so 5, 1. Alright, so let's say we want to know what is the what's the distance between these 2 points. So I'll draw a segment between them. So here's a line segment. In geometry, we would call that AB, right, with a little bar over it for a segment. If we want to know how long it is, and we're talking about the magnitude of it, and we would just use AB without the bar, since we want a quantity that represents how long it is. So we can just use Pythagorean's theorem. If you remember Pythagorean's theorem from high school or another class you took, let's see. think that's how you spell it. Pythagorean theorem says that a squared plus b squared plus a squared plus b squared equals c squared. Alright, I was just looking at a little clip. I don't know if you guys have ever watched The Wizard of Oz, but I think the Scarecrow, he tried to say the Pythagorean theorem after he got his little diploma from the Wizard of Oz, and he completely screwed it up, so I thought I'd go ahead and play it for you here. Let's see if we can hear it.
Great learning, where men go to become great thinkers, and when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D. Ph.D.? That's Doctor of Thinkology. Some of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, joy, rapture. I've got a brain. How can I ever thank you enough? Well, you can.
So, if you listen to that little part, I think he screwed that up. So you might want to look on the internet. It's fun to, there's a lot of stuff on there about that. First of all, he said an isosceles triangle, right? Whereas Pythagorean theorem is all about right triangles. So that was one of his mistakes. So how can we use that to find the distance here? Well, we can think of this as the hypotenuse of a right triangle. So if we just go down right here and go over from here, we've created a right triangle, and this would be a leg, and as we can clearly see, the length of that leg is 3, and this would be a leg, and the length of that leg is obviously 4. So now we can use Pythagorean's theorem, to figure out the longest side, which is C, right? So remember, C is always the longest side. So this is going to be 3 squared plus 4 squared equals, we don't know, so we'll just call it C squared. And that's 9 plus 16, which is C squared. So that's 25 is C squared. And when you take the square root of 25, the primary root is 5. So the length of that missing side is 5. So that's the idea behind it, what we're going to be doing here in a minute when we do the distance formula. So if I take any other points, let me see if I can use a blank sheet of paper here. So let's say we don't know what the coordinates are. So I'm just going to draw, we have some point here and some point here, right? Since this blank piece of paper doesn't have any coordinates on it, we don't know exactly where it is, but we can call this right here, we can call this point 1, and we'll call the x value x1, and we'll call the y value y1. And this we'll call point 2, and we'll call the x value x2 and the y value y2, since we don't know what they are. Alright, so the same situation applies, right? I'm looking for the length, or the distance, between point 1 and point 2. I know that I can create this right triangle here, right? And if I just knew this side right here, how long it is, and this side right here, then I could use Pythagorean's theorem and just figure out how far it is from point 1 to point 2. Alright, so, well, how do you figure out, how tall the triangle is? Well, that's really just a difference between the y values of these coordinates. So, for instance, if I look back at our example here, this was 3, which is the difference between these two y values. So, the distance from -2 to 1 straight up is 3. 1, 2, 3. If you subtract them, -2 minus 1, you get negative 3. Or if you do 1 minus negative 2, you get positive 3. Either way, it's not going to matter because I'm going to square it, and if I get a negative when I square it, it's going to become positive anyway. So the order in which you subtract isn't going to matter for this formula, right? So in this problem then, this distance right here is just the difference between y2 and y1. So this is y2 minus y1. And technically, since we're talking about distance, I do want that to be positive, even though when I plug it in the formula, it's not going to matter. So we'll put absolute value bars around that just to be, safe, and say, all right, now it can be a distance because it will be, no matter what, it will be a positive value, right? So for instance, I could call this y1 and I could call this y2, and if I did that, then these would be swapped and I would get a negative number. So the absolute values just make sure that you get a positive value there. So what would this one be? Well, this is a horizontal leg, so its distance is going to be the difference, or the length of that leg is going to be the difference between these two x values, right? So that's going to be absolute value of x2 minus x1. And we'll call this D. The reason not C, because the distance formula that you have in your book here, here it is right here. As you can see, it uses D. So I'll use D. Alright, so now what I want to do is, using c squared equals a squared plus b squared, I will use, I'll just plug in what I have here. So instead of c, I have d, so I'll replace that with d squared. And I'll call this one a. So the length of this side is this, so that will be x2 minus x1 squared plus this side's length, which is the absolute value of y2 minus y1 squared, right? Alright, so I want to solve for d, so what I do is I take I forgot my little absolute value thing there. I take the square root of both sides. So if I take the square root of this side, I get d. And if I take the square root of this side, I get the square root of all of that. And since I'm squaring it, I can go ahead and drop the absolute value bars now. So remember, when you square a number, you get a positive value. So they're not really needed now. So x2 minus x1 squared plus y2 minus y1 squared. And there's formula for the distance formula. Alright, so let's use it with the problem I did here. Let's go ahead and use it and see if it works. So using these same two coordinates, right, if I were to ask you to find the distance between A, which is 1, negative 2, and B, which is 5, 1. Alright, so this is your x1, this is your y1, this is your x2, this is your y2. Remember, I could swap those out, it wouldn't matter. I could call this one x2, y2, x1, and y1 if I wanted to. But if that's x2, that has to be y2, right? You can't call this x1 and that y2, for instance. That wouldn't work. Alright, so the formula says, well, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. So now all we have to do is plug in. So x2 is, what, 5? And x1 is 1. we're going to square that, plus y2 is 1, and y1 is negative 2. I'm going to square that. And remember, answer needs to come out to be 5. Otherwise, I've made a mistake or my formula is wrong. Alright, so d equals the square root of 5 minus 1 is 4, so that's 4 squared, plus 1 minus negative 2 is positive 3, so that's 3 squared. So that gives you the square root of 16 plus 9, which is the square root of 25, which is 5. Alright, so it works. And that's an example of using the, actually that's the derivation of the distance formula right here. You can find that in your textbook as well. Alright, so what about the midpoint? Let's look at that. Where's the middle of segment AB? Well, if I go over 1, 2, 3, 4 to get to the end, then I should go over 2 to get to the middle, right? That makes sense. So if I go over 4 and up 3, then to get to the middle, I go over 2 and up, what, 1.5? So the midpoint is right there. It's 2 over and 1.5 up. Where's that coordinate? Well, we're at 1 right now, right? So this is at 1, so I go over 2 more, that's at 3. So then this has got to be at 3. And what did we do? We went up 1.5 from here, so we were down at negative 2. So if I go up 1, I'm at negative 1. And then up 1/2, I'm at negative 1/2, right? So that's right there's negative 1/2. So that's the, just using the picture, that's an easy way. Sorry about that there's the midpoint. That's an easy way to find the midpoint just by looking at a picture, if it will fit. But the coordinates could be really large and you can't draw a picture. So there is a formula. Basically, to find the midpoint, all you have to do is take the average of your two x values to get the new x value, right? So for instance, the average of 5 and 1, what do you do to find the average of two numbers? You just add them and divide by 2, right? So 5 and 1 is 6, divided by 2 is 3. And what's the average of negative 2 and 1? Well, you add them. That gives you negative 1. Divide by 2, negative 1/2. All right. So the midpoint formula then. Basically is, what do they call it in the book? I think they use a capital M to indicate the midpoint. So the midpoint of some coordinate x and y between 2 points x and y, you find by doing the average of the x's, so x1 plus x2 divided by 2, and the average of the y is y1 plus y2 divided by 2. And voila, there's your midpoint formula. Alright, let's, I'm going to look at a problem in the book. So, some of these questions are asking you to confirm, for instance, that a triangle is a right triangle, right? So I'm going to look at 37 in the book. It's on page 95. So page 95, problem 37 gives me point 1 is 3, negative 4, and point 2 is 5, 4. And the question states, find the distance between the points. So I can just use this formula right here, D. So let's go ahead and do that. You might want to pause the video and try to do it on your own before you watch me do it. Make sure you can do it. Let's see. So the two x values are 5 and 3. So that's 5 minus 3 squared plus, and the two y values are 4 and negative 4. So 4 minus negative 4 squared. So what is that? 2 squared plus 8 squared, which is 4 plus 64. So the square root of 68 is the answer to that one. I think when you do your homework on My Math Lab, they're going to want that in simplest radical form. So you're going to want to figure out, some of your calculators might do that now, I don't know, but I know 4 goes into that, and what we're looking for is perfect squares, like 4 and 9 and 16 and 25. If you remember, perfect squares that go evenly into this number, so we can take them out. So let me look at 68. 68 divided by 4 is 17, and 17 is prime, so I don't need to look any further. 4 is the largest perfect square that's going to work, so this square root of 68 can be broken down into 4 times 17, right? Now the square root of 4 is just 2, so I can bring that out from underneath the radical sign as a 2, so that's 2 square root of 17, and now it's in simplest radical form. Alright, so let's look at, let's see if I can turn this thing over. Let's look at number 49. Let's see that. Alright. So problem 49 says plot each point and form the triangle ABC. Verify that the triangle is a right triangle. Find its area. So the two coordinates are -2, 5, and actually there's 3. B is 1, 3, and C is -1, 0. Alright, so if we can draw a picture of this. Alright, -2, 5, that would be over 2 and up 1, 2, 3, 4, 5. So that's right there. So there's A. B is 1, 3, so over 1, up 3. So there's B. And -1, 0 is here. So there's C. Alright, so question is this a right angle, right? If it is a right triangle, that one's got to be the right angle. Well, we can check Pythagorean's theorem. We could see if the distance from A to B squared plus the distance from B to C squared equals the distance from A to C squared. That's one way to check it. If you remember, there's also a slope thing, which is much easier actually. So I know that, for instance, the slope of this, I'm jumping ahead a little bit, but nothing wrong with that. We can go up 3 and over 2. So the slope of CB is, what, 3/2, right? And the slope of AB is what? Down 2 over 3. That's negative 2/3. And since these are negative reciprocals of each other, in other words, if you flip this one over and change the sign, you do get this one here. Then from that, I do know that that is a right angle. These are perpendicular line segments. So I know it's going to work. I think the idea is that we find these lengths and we plug it into to Pythagorean's theorem and see if they come out to be equal. So first I need to figure out, well, what is the length of AB? Right? How long is AB? Well, I can form, let's see if I can use a different color pen right here. I don't know if this is going to work, but I can form a right triangle right here, right? So that's what, 3, and that's 2, right? So I know that AB squared is equal to 3 squared plus 2 squared, which is what, 9 plus 4, which is 13. So AB, if AB squared is 13, then AB not squared would be the square root of 13. Alright, well, I can do the same thing. Remember, this is the other leg right here, so I can make a little triangle here. And if you notice, it's congruent to this triangle here, right? Because that side's 3 and that side's 2. So if I go through the motions of using Pythagorean's theorem, I'm going to get the same exact answer, right? So therefore I know that CB is the same. So this is an isosceles right triangle because these two legs are equal in size. Alright, well, what is this one here? Well, if I draw this little right triangle here, this has a length of 1, 2, 3, 4, 5. So the height of that triangle that I just formed is 5. The base is 1. So AC squared is 5 squared plus 1 squared, which is what? 25 plus 1. So that's 26. Therefore, AC not squared is the square root of 26. Well, does Pythagorean theorems work, right? So does AB squared plus BC squared equal AC squared? I guess I didn't really need to take the square roots because I really just need the squared numbers, don't I? And it does work. So AB squared is 13. BC squared is also 13. And AC squared we found was 26. So yeah, that works. So that is in fact a right triangle by Pythagorean's theorem. Alright, I think that's enough for this video. You might want to take a break anyway. I'll come back and do a few more problems, try to finish up the chapter. Thanks for watching.